So what I was referring to, if you guys remember, so last class period, oh, Daria, all right, I'm really excited for this one. So if you guys remember from last class period, we talked about compound interest, right? And the power of compound interest, right? So what we want to do is you guys can see that, hey, saving some money or investing some money was pretty cool, right? I mean, we made some money without doing anything, right? That was very cool. So I wanted to kind of think about, well, what if I created a project to encourage you guys to save? So let's say I create a kind of program where I give each and every one of you a $100 bill today. All right? Then if you show up and you come back to me next year at this exact same time, I will give you 100% interest on your money and give you another $100 bill. Therefore, then you'll have $200. Everybody follow me? And then if you come back the next year after that, I will give you $400. Okay? So it looks something like this. X. Oh, forget the xy's. So this little activity works with, so kind of 0, like right now, because that's how time has passed, you'll be given 100. After year 1, after 1 year has passed, you'll have $200. Year 2, you'll have $400. Year 3, $800. And year 4, $1,600. Now, if you could make sure, if you guys could go ahead and think about what would be maybe a good equation that we could use to represent that problem. Does anybody know off the top of their head what they'd be? Yeah?
Y equals 2x plus 100.
2x plus 100?
Or is it just 2x?
I don't know. Do you have one? I said we have 1 equals y equals 2x plus 100.
Or 200x.
No? 200 times x?
Yeah, because if it's, well,
Tricky. It's something we've done. Yes?
100 times 2 to the x.
Yeah, so it's an equation actually that we haven't really worked on. So if we said this was x and this was y, it's close to yours because yours worked for some of them, but yours stops working like 200 or 2x, like 200x, stops working at once you get up to like 3, right? Because that would be 600. So what you look at is you actually see these are squaring. So the equation looks something like this. 100 times 2 to the x, right? Which is an exponential function, which you guys probably forgot. But we did go over this in Algebra 2, all right? So now, anyways, if you guys remember, though, you were given $100. And then after a year, you earned $100, correct? So really, this equation could look something like this. $100 times 1 plus 100% raised to the x. Right? You got your you have your $100 plus you earn 100% of your money, correct? And therefore, in that time period, this is going to represent how many years, basically, or how many times we're going to compound. So if you did it for 1 year, x would equal 1. If you did it for 2 years, that equals, that the whole thing's going to be 400 and so on and so forth. Does that make sense? All right, let's look at this graphically. So let's say year 1. All right, so you guys are given $100. OK? So you're given $100. And so this is after year 1. So after year 1 has passed, now you're still going to have your original $100. But now you're going to have earned another $100. Would you guys agree? Yes? Right? So cool. You now have $200. That's not bad, right? That's pretty good. But can it get better? And here's what we kind of need to look at. If you kind of draw a line from there to there, that wasn't too bad. That was better than my other classes. What I want you guys to see is I give you $100 today. Nothing happens, nothing happens, nothing happens, nothing happens, nothing happens, nothing happens. Oh, a year has passed. Boom, I double your money. Right? Not too bad. But do you see this like open? Do you see this little triangle here? This kind of triangle, what that represents is lost opportunity. Your money did not do anything for you in this opportunity. Your money was basically worthless until after a year. Then after a year, boom, compound interest. You earn money, on your interest, right? But what if we could like earn some money in here? So what if I said, let's try, what about this? Well, actually, one of you might say, well, Mr. McLogan, why do we have to wait? Why don't you just why don't we do 50% at the beginning, 50% 6 months, and then the other 50% after that? So it looks something like this. Where did I lose my marker? Did I lose that thing? Do you have the top? Did it fall over there? Oh, there. Sweet. Thank you. So if I was going to write something like this, it'd be y equals 100 times 1 plus. So again, the idea is I'll still give you 100% interest for the year, but I'll give you 50% at 6 months and then 50% at the end of the year. So we'll have 100% divided by 2. And then remember, x represents how many times we compounded. Well, here we're compounding every year. So if we're going to do 2 compounds in a year, this number is going to be 2. All right, so in reality, this looks like we're really doing 50% of our money squared. Now, you can go and calculate this, but I'm going to kind of do it step by step. So we have $100. Let's calculate 50% of $100 is 50. Okay. Then we got to calculate $50, or now we're at the end of the year. Now we got to calculate 50%, but we're not calculating. Now we're calculating 50% of 100 plus the 50. So 50% of 150 is going to be 75. $75. You guys kind of see? Is that? Yeah, kind of cool. Okay. So what happened is now, by doing this, you guys can see if we're earning money in these boxes, we're earning money. We just reduced the dead space that your money is working on, right? Well, why about we further reduce this? Why don't we go into quarterly? So now let's have our money work every 3 months. 3, 6, 9. Okay? Let's have this money work every 3 months, or 4 months, 3 months, quarterly, 3 months. So at this first case, after 3 months, so that equation is going to look something like this. So you have $100 times 1 plus 100% divided by 4 raised to the 4th power. OK? So now, so you have your $100 initial investment, right? Here's your $100. Let's earn 25% of $100, ends up equaling $25. You guys feel me? Right? Now, second quarter comes in. Now we have to do $125 on that. So boom, 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 boom. And I'm sorry, my graph is not going to be all working from there. So therefore, I have $25. Then do 125 times, oops, I guess I forgot to write this, what this equals. Times 1 plus 25%. You OK, James? So it's 125 times 0.25. That equals 31.25. OK? Then, after 31.25, now we need to do 25% of this plus your 100. So I do 100 plus 25 plus 31.25. And I do times 0.25. And I get 39. $25, 31, 39. OK? And then last but not least, I have to add that to my grand total. Now I need to do 25%. So 1, 2, 3. I need to do it 4 times. This is the end of the 4th quarter. So I do 25 plus 31.25 plus 39.065 times 0.25, something I didn't add up right. 20, oh, I forgot one. So I forgot the 100. Oops. 100 plus 25 plus 31.25 plus 39.065. I lost Hallie. Times 0.25 is 48.828. So what I want you guys to kind of see, what's kind of happening here. And, well, actually, what's kind of happening is all these little chunks for my 100, 200 is getting kind of cut up, okay? They're basically what's happening is all this chunk of money where my money is not working for me is getting smaller and smaller and smaller, okay? What you guys, like these areas, and let me actually, these points where my money is no longer working for me is getting smaller and smaller. Now, in this case, you guys can see I have like this section. I have this section. And then you could kind of work in, you know, these are kind of be filled in, your money's kind of work for you. So what's happening is by working into these quarter sections, more and more of my money is working for me, right? Instead of breaking up into fourths and into eighths, the more and more and more of my money is working exactly for me. So if we kind of take this into a list, if we only compounded it once a year, so x equals once, we end up equaling $200. When x equals 2, we end up having we end up having 225. And then we worked into x equaled 4, which would have been, let's see what that is. That's going to be 48.828 plus 39.065 plus 31.25 plus 25 plus 100. And that equals 244.143. So my question to you guys is I keep on getting more and more of these. Am I going to get more and more money? Yes. Can I get infinite amount of money? What do you think, Daria? No? So I could break this up, but I'm not going to get infinite amount of money because the more and more times I compound, think about it. If we compound, right now we've compounded semi-annually, then we did quarterly. What if we did monthly? What if we did yearly? I'm sorry, not yearly, but daily, hourly, by the second, by the nanosecond, millisecond, whatever the other seconds things. But we could basically get on and on and on and on. Would we get infinite amount of money, Nick? Yes? Well, so what we're basically looking at, instead of n, actually let's look at this. So basically what we want to know, x represents the number of times that we're chunking this up, right? So why don't we find the limit as x approaches infinity, okay? Now, if we go back and look at these equations, if we write this in decimal form, this is really 100% in decimal form is really just 1. So we could write this as 1 plus 1 over x raised to the x. And let's figure out what happens to the limit as x approaches infinity. So I'll go over to Desmos. And I'm just going to type in the equation. So I have 1 plus 1 divided by n. I'm sorry, not n. We're using x, aren't we? Raised to the x. I'll just use y equals. So as you guys can see, when you guys look at this, you can see that 0. We're actually undefined at 0. So it gets really, really close to 0. But then you can look at this slope of this line. It's increasing really, really rapidly, right? You guys can see from 200 to 225 to 244. Really, really close. It's increasing. But then it starts to taper off, right? It doesn't get as fast anymore. It starts slowing down as far as how fast it's increasing. So let's go and take a look at this, and let's play with some numbers. Duplicate table. So what we talked about, we did quarterly, which was 4. Now, oh, I forgot one last thing. I'm sorry. what you guys see that this $100, all this is doing, this $100 is magnifying this. So I chose just to do, you could do this with the 100, but I'm just going to do it as 1 because the 100 is just magnifying our amount. Okay, that's why I chose this format. I didn't use the 100. So that's why we're starting at 1. If I didn't have the 1 here, it'd be 100, and everything would be magnified by 100. Does that make sense? That's why we're at 1, because really there's a 1 in front of here. So I apologize for that. I forgot to mention that. But anyways, we had what, $244, right? And here I have 244. You guys see that? So my math is right. It's just a difference of 100. Now let's go and take a look. What would be monthly? Monthly would be 12, right? So I hit monthly. That's at 2.6. Not too bad. What about daily? 365. So 365, 2.71. Now how about hourly? So let's see, 24 hours in a day times 365, 8,760. Do you guys see something now? See, as we're getting closer and closer, right? It's not really getting that big anymore. Let's do minutes. What about if we did 60 minutes times 24 times 365? So that's 525,000. 525,600. And as you guys see, no, it won't do it anymore. But do you guys see here? That's what, 2.718, right? Again, it's getting closer. It's not increasing as much, right? So it looks like we're kind of approaching a number, doesn't it? And if you guys go back and look at the graph, doesn't the graph look like there is a horizontal asymptote, right? A number that we are approaching that we're never going to meet, but we're actually approaching from the left and from the right. This doesn't really make sense in the context of our problem, but you guys can see it looks like it's approaching a horizontal asymptote. So what is this number that we are approaching? It looks like this number is approximately 2.718. Okay? And this number is E. Now, before I finish up, or before I wrap everything up, I want to put it into context again so you guys can think about this. Our money is increasing, right? The more and more times we compound within a year, right, the faster and the more and more money we're making, right? But there's a limit to that, right? Limit. Hint, hint. Limit. There's a limit to how much we can increase. And that limit is E. So you can think of E as kind of like your governor. It's like your speed limit. It's saying you can only go this fast. Because we know infinitely, guys, I mean, you can only compound something as fast as you can compound. So your kind of speed limit or your governor is going to be E, which is just approximately 2.71. It's an irrational number. And irrational just like pi, but that exactly is your basic understanding of E.